Hi everyone, welcome to YourPedia Education. This is Chandrasekhar, Faculty of Electrical and Electronics Engineering at YourPedia. In this video, I am going to discuss about NPCIL interview preparation in electrical engineering. You all know that NPCIL interviews are out, people are preparing for interviews. So how to prepare for NPCIL and in electrical engineering especially. And some questions from the subject power system also I am going to discuss. See, NPCIL is a very good reputed organization. The preparation, interview preparation of NPCIL is somewhat different from other PSUs. See, the preparation of BARC, NPCIL, DRDO, ISRO. So these things are somewhat different from other PSU interview preparation. So in NPCIL, mostly your preparation should be technical. I can say 95% should be technical your preparation because there most of the questions will be technical questions, and the questions will be like suppose if they ask one question from electrical corona, from there they will extend in multiple directions in NPCIL. In BARC, yes, BARC interviews are also going. Yes, in this month there are for lots of candidates BARC interviews are scheduled. For BARC they go more depth than NPCIL. NPCIL is not the depth, but BARC is going to be more depth than NPCIL, right? So any 5 subjects they will ask you to choose. Yes, I suggest you to choose 5 favorite subject of yours from electrical engineering. And some people they are saying that sir, network is not my favorite subject. See, network should be your favorite subject, but because that is a basic subject of either electrical or electronics engineering, right? Either electrical or electronics. If you learn this subject or if you prepare this subject, then it will help you in the preparation of remaining subjects also. So the subjects you may choose for NPCIL preparation are, I can say, first one is electrical circuit analysis or network analysis. Yes. Second one is say after networks, if you are interested towards signals and systems, you can take signals and systems also, but for signals and systems, ECE students are more inclined than electrical students. You can go for electrical machines, yes. Then the next subject is yes, power systems, yes. The next subject is power electronics, and you can go for after this. Can I go for control systems? Yes. See, in fact, after first subject networks, you can go for control systems also. There's no restriction. Control systems. See, control system also. So I can say sequence may be any. You can say control systems first, then networks, then electrical machines, then power systems, then power electronics, like that. And you have electrical measurements also. Electrical measurements, yes. Electrical measurements is also one of the subjects, right? Electrical measurements. And you can go, if you want, you can go, sir, I am more interested in digital electronics. Yes, you can go with digital electronics. Sir, I am very good at signals and systems. Yes, you can go with the signals and systems, right? Signals and systems. And you can choose, if you want, you can choose engineering mathematics also. Mathematics also you can choose. But the thing is, you must be good at that subject. You must be very good at that subject, right? So in this video, I will discuss about the topics of power system. Yes, I'm the faculty of power system, electrical machines, and control systems and networks, right? So in these subjects, I'll be taking mock and snap interviews. So when it comes to power systems, yes, when it comes to power system, the important topics are the topics you have to prepare are mostly means. See, I can say that every topic is equally important. But the topic where more depth of discussion is there, these are the topics. The first one is transmission. So in transmission also, see, transmission starts like this. Transmission rating of transmission line, right? With what material transmission line is made up of. From there onwards, you have voltage control, you have transient analysis on transmission lines like reflection, refraction, reflection coefficient, their physical significance, and underground cables, steady state performance of transmission lines, and voltage regulation, efficiency, right? Voltage regulation, efficiency, classification of the transmission lines, and see, I can say totally transmission. In the transmission itself, a lot of topics are there. Those topics are, I can say, in transmission, I can say steady state performance of transmission lines, transient analysis of transmission lines, underground cables, corona, Ferranti effect. Yes, Ferranti effect is one of the important effect. Ferranti effect, how to reduce Ferranti effect, how to improve the voltage, how to improve power factor. Yes, if you go to voltage control is one of the good topic. It is having a lot of applications, so you can put your brain in voltage control topics. There is a scope of discussion in the topic called voltage control, right? So voltage control and power factor correction, transmission. Then after that, I can say fault analysis. Yes, fault analysis is also one of the important topic. Fault analysis. The questions on fault analysis will be what is the purpose of? See, they'll start with a very simple question first. Why we are studying fault analysis? What is the purpose of fault analysis? Then you'll give some answer. From there, like that, they keep on proceeding. And after that, stability analysis. Yes, stability analysis. Stability analysis. Then load flow studies. Yes, load flow studies. Load flow studies. Then power system protection. Power system protection. Yes, power system protection. These are very important topics, right? You must prepare all these topics in power system protection, especially about the relays, circuit breakers, relay characteristics, right? Relay characteristics. So there are some special cases where why we should not use reactance relay in the protection of long transmission line. Why only more relay is used in the protection of long transmission line. In fact, impedance relay, reactance relay, more relay, these three relays are distance relays, right? Distance relays. What is the purpose of CT? Okay, current transformer. And can you draw the basic protection scheme and explain how it works? And they will use some schematic diagram in that. Suppose the circuit breaker here got stuck, it is not operating, then what should be the which circuit breaker will be the next line of defense? So this kind of questions will be asked from the power system protection. And about circuit breaker, arc production, why arc is getting produced, how to quench the arc, what are the various methods of arc quenching, right? And what is current chopping phenomena? Like that, many questions are possible in power system protection. And they may ask some few questions from the PLC and SCADA also, if you have done anywhere some internship or mini project, or you have some experience, right? Suppose some people will say that, sir, I did my internship, 6 months of internship or 3 months of internship in a steel plant or somewhere in the substation. Then they will ask about the equipment of substation also. So be clear with your subjects. So clarity is very much required. Some people, they just know the answer, but they don't know why it is and what it is and how it is. For any interview like NPCIL, BRC, I told you already, ISRO, DRDO, for these kind of interviews, how it is, why it is very, very important. Clarity and good amount of explanation is required from your side for the asked question, right? And they will ask you to draw the diagrams also, schematic diagrams also they may ask you to draw, right? The difference between NPCIL and BARC is, in BARC they go more depth, but in NPCIL that much depth is not required, but up to some extent the depth is required, right? So let us see some sample questions. That is the first question I am asking. These are the questions which were asked previously in NPCIL and BARC, these kind of interviews, right? Yeah. The first question is, which fault is more severe? Which fault is more severe? Which fault is more severe? Yes. Yeah, the severity of a fault, first of all, one must know that the severity of a fault is decided by the fault current or the short circuit MVA. Severity of a fault is decided by fault current or short circuit MVA. Now, for this one, the answer is, most of you know the answer, but how is very important. You know that triple L fault. Triple L fault. The answer for this question is triple L or triple LG. Both are same. Physically there is a difference, but electrically there is no difference between triple L and triple LG. Why? Because both are, I can say, balanced faults. Triple L or triple LG or three-phase fault is more severe. Fault is more severe at all the locations in the power system network, at all the locations in power system network, except on generator terminals, except on what? Generator terminals. So on generator terminals, LG fault is more severe, right? On generator terminals, yes, LG fault is more severe. LG fault is more severe, right? LG fault is more severe. Now you will ask, why on generator terminals LG fault is more severe? Yes, the question, continuation of the question. The second question which got framed from the first question is why, yes, LG fault on generator terminals, is more severe, right? Why LG fault is more severe on generator terminals? Let's see the fault current formulas of both LG fault and triple L fault. For triple L fault current of three-phase fault, that is equal to simply E1 by X1, whereas the same for LG fault will be 3E1 by X1 plus X2 plus X0 plus 3xn plus 3xf, where xn is neutral to ground impedance and xf is fault impedance. For time being, let's take xn and xf as zeros. Yes, so solid grounding, solid fault, solid grounding, solid fault, right? Now if of LG fault is equal to 3E1 by x1 plus x2 plus x0. But we all know very clearly that for a synchronous generator, x1 is approximately equal to x2 if you take a cylindrical rotor synchronous generator. If you take cylindrical rotor synchronous generator, x1 is approximately equal to x2 and x0 is negligible. See, for synchronous generator, yes, approximation I'm taking, for synchronous generator, x1 is approximately equal to x2 and x0 is neglected. Then fault current IF for an LG fault is equal to 3E1 by x1 plus x2 plus x0 is neglected. Therefore, that is 3E1 by 2x1, that is equal to 1.5E1 by x1 approximately. You see, the fault current of triple L fault is E1 by x1, whereas the fault current of LG fault is 1.5 E1 by x1. So on the terminals of synchronous generator, yes, LG fault current formula, LG fault current is more when compared to triple fault current. Therefore, on generator terminals, LG fault is more severe. The next question that can be framed here is, see, you see the connection. So here the discussion happened between LG and LL faults, LG and triple L faults. Now he will ask you, what happens if neutral of synchronous generator is left ungrounded in case of LG fault. Most of you would study this kind of cases. Just you'll study standard examples. LG fault with the by default neutral grounding. What happens if neutral left ungrounded? Let us see. For that one, see, some people, what the mistake they do is, sir, for the first time we are encountering this kind of question. Don't worry. First you make the diagram. What they expect you is not to give the perfectly correct answer, but your approach towards the question is very important, right? So take the synchronous generator. Yes, I am taking the synchronous generator here. This is phase A. Yes, and this is phase B. Yes, and this is phase C. This is neutral. Neutral is left ungrounded. It is not connected to ground. It is not connected to ground. Now this is our generator. On this phase A, LG fault has been occurred. LG fault has been occurred. Here there is a relay and circuit breaker. Here there is a relay and circuit breaker. Here there is a relay and circuit breaker. Right. So this is phase A, phase B. This is EA. This is EB. This is EC. This is ZA. This is ZB. This is ZC. Now see. For example, let's understand that fault current is flowing. Let's assume that fault current is flowing. Fault current is coming from phase A. When it is coming from phase A, current phase A, again it has to end at phase A. Now from ground, but here there is no closed path, therefore fault current will not flow first of all. If the neutral of the generator is left ungrounded in case of LG fault, fault current will not flow. There is no closed path for the flow of fault current. Now people will say, sir, it's a good condition if fault current is not flowing. No, it's not a good condition. Because if fault current is not flowing, circuit breaker and relay is not in a position to recognize the present condition as fault condition. If relay is not in a position to recognize the present condition as fault condition, it cannot give the trip signal to circuit breaker. Therefore, circuit breaker is not in a position to open its contacts, and fault cannot be isolated from the existing system. Fault cannot be isolated from the existing system, right? Therefore, there must be a closed path. This is one of the disadvantage. Another disadvantage is this small amount of fault current will flow. Then you may ask a question, sir, where is the closed path for the flow of that small amount of fault current? You know, there is capacitance. There is capacitance which is formed to the ground. So that fault current is making closed path these phases, but this capacitive current is very small because it's not conduction current, it is displacement current. Fault current is very small, so current is flowing IF, but very small amount of current is flowing. Relay and circuit breaker relay cannot recognize that condition as fault condition. Small amount of current is making closed path again through this way also it is making closed path. Now, if you find the phase voltage of these existing phases, how to find the voltage? Yes, you have to make a closed path. Then, because of this charging current flow, the phase current. These two phase currents. This is phase A. This is phase B. This is phase C. Phase A, on phase A fault is there, but on phase B and phase C there is no fault. But because of this small amount of fault current which is flowing through the capacitances of the remaining two phases to make a closed path, that is causing the phase voltage to rise up to line voltage. Due to which insulation will fail, and phase B and phase C are also entering into the faulty region. There on phase B and phase C also faults are occurring. In turn, it is going to create a triple L fault, right? So this is called as arcing grounds phenomena. What is arcing grounds? It is a rise of healthy phase voltages to line value if the neutral of the generator is not grounded in case of LG fault. This concept is called as arcing grounds. To avoid this one, definitely neutral of the synchronous generator must be grounded, right? Now the same question can be extended, not same question, same concept. That is suppose if neutral of the generator is not grounded in case of LLG fault. See, question is if neutral of synchronous generator is not grounded in case of LLG fault, what happens? This is very simple thing. But you should not get scared of the question. Many people, what they do is they get scared of if they don't know something. Means if they are listening it to the first time, no, they get scared, right? So that is not required. In fact, you can answer this question. This is phase A, phase B, and phase C, right? This is a neutral, and this is not grounded. It left ungrounded. It left ungrounded. So phase A. Suppose previously the fault is there on phase B and C. Phase B and C fault is there, and to the ground. Yes, and to the ground. So this is IB. This is IC. This is IB. This is IC. Now the total current is fault current that is flowing in this one. The total current is fault current that is flowing in this one. But here there is no closed path. Here for the flow of fault current there is no closed path. What happens is the fault current will flow between B and C only. No more it is going to be an LLG fault. It behaves like a LL fault. Why? Because though physically it is connected, but here the current is zero. Here the current is zero. Why? Because there is no closed path. There is no closed path. Here open circuit is there, right? So as there is no closed path, LLG fault will behave as simple LL fault, right? So this way questions can be asked on power systems, especially in fault analysis. We will be continuing this series. I will be discussing the questions on power systems for both NPCIL and BARC, control systems, networks, and electrical machines. Thank you.